Magandang araw my dear students, kumusta? I hope you are in good condition and in good health. Last meeting we discussed hypothesis testing using the p-value method, but this lecture video I prepared will focus on the traditional method. Though it is traditional and researchers usually use the p-value method nowadays, it is still important to study the traditional method of hypothesis testing, especially that your field of specialization is mathematics. Okay, so before I start this lecture, I will first present the rules in dealing with this lecture video. First, do not capture or record any portion of the lecture video. Second, do not upload any portion of the lecture video in Facebook, Messenger, YouTube, and other media platforms. Third, this lecture video is intended only for the consumption of you, my dear students. So do not share the link the YouTube video to other students and teachers. The following are the learning objectives for this lecture. At the end of the lecture, you should be able to conduct hypothesis testing using the traditional method, determine when to use z-test and t-test, compute for z-test both one sample mean test and two sample mean tests, and interpret the computed value using the traditional method of hypothesis testing, and compute for t-test and interpret the computed value using the traditional method of hypothesis testing. Now, we discuss the steps in hypothesis testing for traditional method. The initial step in conducting tests of significance of the observed measurements is done by making an assertion regarding the nature of the distribution of the data. Generally, we assume that the data under consideration is normally distributed. Especially when we are dealing with parametric tests, you really need to prove that the data are normally distributed before you use parametric tests. So the first step is to formulate the null and alternative hypothesis. Second, determine the statistical tool to use. Third, specify the level of significance. The most commonly used values of alpha are 1% and 5%. Fourth, determine the tabular or the critical value. Fifth, determine the computed value of the test statistics from the given conditions. And sixth, make a decision. In making a decision, we compare the computed value to the critical value. We shall have two possibilities. So if you can still remember, in the p-value method, we compare the p-value method to the significance level. But in the traditional method, we compare the computed value to the critical value. So I will teach you later how to determine the critical value or the tabular value in both in z-test and t-test. So these are the two possibilities. If the computed value is less than the critical value, we accept the null hypothesis. And second possibility, if the computed value is greater than the critical value, we reject the null hypothesis and accept the alternative hypothesis. Ulitin ko kung ano yung two possibilities in making a decision. Napaka-importante na i-master nyo to. So, if the computed value is less than the critical value, we accept the null hypothesis. And if the computed value is greater than the critical value, we reject the null hypothesis. And of course, if we reject the null hypothesis, we accept the alternative hypothesis. We already discussed last meeting on how to formulate null and alternative hypothesis given a research problem. So the first step that should be done in conducting tests of significance is the formulation of the hypothesis to be tested. Generally, a hypothesis to be tested should be stated in terms of a specific parameter or parameters of the population. The concept of hypothesis in statistical inference is classified into two, which are null hypothesis and alternative hypothesis. The null hypothesis, denoted by H0 or H sub O, refers to the statement that the absence of any effect claimed for a certain action. This hypothesis also asserts the absence of difference between the observed and expected values. The alternative hypothesis, denoted by HA or H sub A refers to the assertion contradicting the null hypothesis. Thus, if the null hypothesis is proven to be true, then the alternative hypothesis should be false. These hypotheses are usually stated as shown in the following. So we have the null hypothesis could be mu is equal to mu sub O. Of course, the possible alternative hypothesis is mu is not equal to mu sub O. And letter B, same null hypothesis, but the alternative hypothesis could be greater than, mu could be greater than mu sub O, and for letter C, mu could be less than mu sub O. Always remember that we use equal sign when expressing a null hypothesis. And for alternative hypothesis, we use inequalities such as not equal, greater than, and less than. We talk about the level of significance. Sample observations are usually taken in random, and this might result in high value of variation among sample statistics. High value of variation results in the rejection of a true null hypothesis. As much as possible, we want the probability of rejecting the true null hypothesis to be very small. The value of this probability is known as the level of significance. The level of significance is usually represented by the Greek letter alpha, where the commonly used values range from 0.01 to 0.10, particularly 0.05 or 5%, and 0.01 or 1%. The smaller the value of the level of significance, the smaller is the risk of rejecting a true null hypothesis. We usually use 0.05 significance level for social researches and 0.01 significance level for medical researches. Now we talk about tabular value. After specifying the value of the level of significance, the tabular value can be determined. This value is sometimes called the critical value. It divided the area of the graph of a normally distributed set of data into two areas, the area of rejection and the area of acceptance. The value of the level of significance represents the area of rejection. The value 1 minus alpha represents the area of the acceptance region. The tabular value when serves as the basis for accepting or rejecting the hypothesis based on the evidence gathered. To illustrate, consider a level of significance of 0.01. This implies that the probability of rejecting a true null hypothesis is 1%. For a two-tailed test, we divide the value of the level of significance by 2 since we have two areas of rejection. Thus, 0.01 divided by 2 is equal to 0.005. Referring to the table of areas under the normal curve, we find that z of 0.005 is equal to 2.575. Hence, we may say that the sample mean would be greater than 2.575 of the standard deviation or less than negative 2.575 of the standard deviation. Adding this 2.5% shall result to 1%, which is the total area of the rejection region. See the given figure. In the case of one-tailed test, the level of significance is no longer divided into 2. Hence, for alpha is equal to 0.01, the z.01 is equal to 2.33. If the alternative hypothesis of a one-tailed test is mu is greater than mu sub O, then the rejection region should be the area above 2.33 of the standard deviation. You can see the figure presented. If the alternative hypothesis is mu is less than mu sub O, then the rejection region should be below negative 2.33 of the standard deviation. See the other figure. Always remember, my dear students, that if the alternative hypothesis has an inequality symbol of greater than or less than, the level of significance is no longer divided into 2 and it is one-tailed. To better understand what I was saying on rejection and acceptance regions, we discussed the z-test and applied the rule. The simplest and most common test on the significance of sample data is the z-test. The application of z-test scores requires the normality of distribution. Also, the sample size should be greater than or equal to 30. Again, the sample size should be greater than or equal to 30 if you use z-test, and the data should be normally distributed. This test is one of the parametric tests since it utilizes the two population parameters mu and sigma. If the population standard deviation is not known, then the sample standard deviation can be used. The z-test can be applied in two ways: one sample mean test and the two sample mean test. This is the formula for one sample mean test. Z computed is equal to the quantity of sample mean minus the hypothesized value of the population mean times the square root of the sample size all over population standard deviation. This table is very important to determine the tabular value for z-test. So we will use that later. If the absolute value of the z computed is greater than the absolute value of the z-tabular, then the null hypothesis is rejected and the alternative hypothesis is accepted. Similarly, if the absolute value of the z computed is less than the absolute value of z-tabular, then the null hypothesis is accepted and the alternative hypothesis is rejected. Let us take this example, my dear students, for one sample mean test. Suppose a sample size of 100 units has a mean of 2.7 and a standard deviation of 1.5. Assuming normality of the data, then test the null hypothesis such that null hypothesis mu is equal to 3 against the alternative hypothesis mu is not equal to 3. Use alpha is equal, or use significance level at 0.01. So if we try to determine the variables, the sample mean is 2.7, the hypothesized value of the population mean is 3, the sample standard deviation is 1.5, and the sample size is 100. So we follow the steps in hypothesis testing. The null hypothesis as given is that mu is equal to 3 and the alternative hypothesis is mu is equal to 3. It's not equal to 3. Mu is not equal to 3. That's the alternative hypothesis. And the level of significance as given, alpha is equal to 0.01. Now we determine the tabular value. So in determining the tabular value, we use this table. The tabular value of z at 0.01 and 0.05 level of significance. So the level of significance is 0.01 and it is two-tailed. Why it is two-tailed? Because the alternative hypothesis is mu is not equal to 3. So, na-discuss natin kanina na kapag ang alternative hypothesis is not equal ang sign niya, it is a we use the two-tailed test. So, looking into the intersection of the two-tailed and 0.01, the tabular value is positive negative 2.575. Okay? So, the computed value of z is yan. I-apply na natin yung formula. Sample mean 2.7 minus 3, which is the hypothesized value of the population mean, times square root of 100, which is the sample size, all over 1.5, which is the sample standard deviation. Yan, ang makakompute nyo is negative 2. That's the answer. So, ayan, ano ngayon yung magiging decision natin? So, sabi natin kanina na kapag ang z computed is less than the z tabular, we accept the null hypothesis and we reject the alternative hypothesis. So, the absolute value of negative 2 is 2 and that is less than 2.575, which is the tabular value. So, sabi natin kanina, kapag ang z computed is less than the z tabular, the absolute value of z computed is less than the absolute value of z tabular, we accept the null hypothesis. Therefore, the mean of the population taken is equal to 3, or i-accept natin yung mu is equal to 3. What if the alpha is, or the significance level is 0.05? Okay, so if we use 0.05, balikan natin dito, ang magiging tabular natin kung sakali is positive negative 1.96. So, 1.96 is, ayan, ang na-compute natin na z computed is negative 2. So, the absolute value of negative 2 is greater than 1.96. In that case, we will reject the null hypothesis and accept the alternative hypothesis. Okay, so ganun yun. Okay, next example. A supplier sells ropes. He claims that the ropes have a mean strength of 34 pounds and a variance of 64 pounds. A random sample of 32 ropes selected from a shipment yields a mean strength of 31 pounds. Are you going to reject the claim of the supplier at 0.05 level? Okay, so let us try to determine the variables. The sample mean is 31. The hypothesized value of the population mean is 34. The population of the standard deviation is 8. Why 8? Kasi ang given dyan is variance. We know that the square root of variance is standard deviation. So, square root of 64 is equal to 8. And the sample size is 32. Again, now we follow the steps in hypothesis testing. The null hypothesis is mu is equal to 34 and the alternative hypothesis is mu is less than 34. Bakit mu is less than 34? Kasi ang sample mean natin is 31 which is less than 34. Okay, so kaya mu is less than 34 kasi ang sample mean natin is 31 which is less than 34. Kaya less than yung inequality symbol natin dyan. Now, the level of significance is 0.05 that is given. Now, what is the tabular value? Again, we use the table. It is one-tailed kasi less than siya. So, sabi natin kanina, kapag less than or greater than ang ginagamit natin sa alternative hypothesis, that is one-tailed. Kapag not equal to, that is two-tailed. So, in this case, it is one-tailed kasi ang alternative hypothesis natin is mu is less than 34. And then, ang level of significance natin is 0.05 that is given. So, ang intersection ng one-tailed and 0.05 is positive negative 1.645. Now, we can compute or we can determine the z computed applying the formula 31, which is the sample mean, minus 34, which is the hypothesized value of the population mean, times square root of 32, which is the sample size, all over 8, which is the population standard deviation. So the z computed is negative 2.12. So the decision is to reject the null hypothesis and accept the alternative hypothesis at 0.05 since the z computed is greater than the z tabular. The absolute value of z computed is greater than the absolute value of the z tabular. That is, the absolute value of negative 2.12 is greater than the absolute value of negative 1.645. Okay, so 2.12, the absolute value of negative 2.12 is 2.12. So that is greater than 1.645. Therefore, the supplier's claim is not true at alpha is equal to 0.05. Hence, mu is less than 34. Since in-accept natin yung alternative hypothesis, so ang true dyan is that mu is less than 34. Okay, now we move on to two sample mean test. Frequent problem usually encountered in statistical inference is to test whether the two samples are taken from a single population. Suppose that mu1 and mu2 are the means and sigma 1 and sigma 2 are the variances of the two normal populations, respectively. The hypotheses that should be tested are, so let's take case letter A case. Mu1 is equal to mu2 and the alternative hypothesis is that mu1 is not equal to mu2. And for letter B, it's the alternative hypothesis is that mu1 That should be mu1. Mu1 is greater than mu2, and for letter C, mu1 is less than mu2. Okay, so this is the formula for two sample mean test. Ayan, mean of the sample 1 minus mean of sample 2 all over square root of the variance of the sample 1 all over size of sample 1 plus the variance of sample 2 all over size of sample 2. So that's the formula for two sample mean tests. Let's take this example, my dear students. An admission test was administered to incoming freshmen in two colleges. Two independent samples of 150 students each are randomly selected, and the mean scores of the given samples are 88 and 85. Assume that the variances of the test scores are 40 and 35 respectively. Is the difference between the mean scores significant or can be attributed to chance? Use 0.01 level of significance. Okay, so i-enumerate muna natin yung mga given. So the variance of sample 1 is 40, the variance of sample 2 is 35, mean of sample 1 is 88, mean of sample 2 is 85, the size of sample 1 is 150, and the size of sample 2 is 150. Kasi naka-indicate doon the two independent samples of 150 students each. So, ibig sabihin, 150 students for sample 1 and 150 students for sample 2. So, let us follow the steps in hypothesis testing. So, the null hypothesis is mu1 is equal to mu2. And then, the alternative hypothesis is mu1 is not equal to mu2. So the level of significance, alpha is equal to 0.01 that is given, and the tabular value at alpha is equal to 0.01. So paano ma-determine ang tabular value natin? Ang level of significance natin is 0.01, and two-tailed siya kasi ang alternative hypothesis natin is mu1 is not equal to mu2. So the intersection of the two-tailed and 0.01 is positive, negative 2.575. Next, we apply the formula and the given. So 88 minus 85, which are the mean sample 1 of mean of sample 1 and mean of sample 2 all over square root of 40. 40 is the variance of sample 1 divided by 150, which is the size of sample 1, plus 35, which is the variance of sample 2 all over 150, which is the size of sample 2. So the Z computed is 4.24. Okay, it's time to decide. Since the computed value which is 4.24 is greater than the tabular value, which is 2.575, then we have to reject null hypothesis and accept alternative hypothesis. Therefore, we can conclude that the difference between the mean scores is significant and can't be attributed to chance. We can conclude further that the examination scores of the students in the first college are better than the second. Kasi nga, lumalabas na may significant difference yung dalawa. Okay, so now we move on to t-test. Okay, so for t-test, in the preceding section, the z-test was implemented based on the following assumptions. First, the data follows the normal distribution. Second, the population variance is known. And third, the sample size is large. That is, sample size should be greater than 30. Yun yung mga rules sa z-test. These conditions, however, can't be met usually since in most cases, population variance is not known, and hence should be estimated from the sample variance. Furthermore, a lot of problems have to be solved even if the sample size is less than 30. If the sample size is less than or greater than 30, then less error can be obtained if the population variance is substituted by sample variance. In conducting tests of significance for small samples, the difference between the population variance and sample variance is large. Thus, it could result to significant error if the z-test is used. This problem could be solved if we use another statistical test specifically designed for small samples and unknown population variance. And we are talking about t-test. So yung mga hindi na-satisfy ng z-test or hindi masasatisfy ng z-test, pwede sa t-test. In z-test, the computing formula is given by, ayan, so na-discuss natin kanina, since population standard deviation is not given, then we shall replace with the value of the sample standard deviation. Thus, the computed value of t shall be t computed is that. Yan yung formula na gagamitin natin. Napalitan lang yung denominator niya, which is the sample standard deviation. The tabular value of t statistics is dependent on two factors, the level of significance and the degrees of freedom. So, hindi na lang level of significance ang gagamitin natin dito, pati yung degrees of freedom. In the case of the level of significance, the value of alpha should be divided by 2 if the alternative hypothesis is, ayan, kapag ginamit natin is not equal to, so parehas lang kanina siya doon sa z-test. If the alternative hypothesis is any of the statements below, ayan, kapag greater than or less than naman, then we should not divide the value by 2. As in the case of z-test, we only have one area of rejection. In the case of degrees of freedom, we shall have the relation degrees of freedom is equal to the sample size minus 1. To illustrate, if the sample size n is equal to is 15, then the corresponding degrees of freedom shall be, so kapag ang sample size mo is 15, n minus 1, 15 minus 1 is 14, the degrees of freedom is 14. The tabular value of t denoted by the absolute value of t tabular can be obtained from the table. So meron tayong another table, parang yung kanina sa z-test, may sarili siyang table. Ang t-test naman may specific table for t-test naman. The value of t tabular can be obtained, or the value of the absolute value of t tabular can be obtained by simply getting the intersection of the level of significance and the degrees of freedom. So we will use this partial tabular value for t-test at 0.01 and 0.05 level of significance. So kukunin lang natin yung intersection ng degrees of freedom and ayun, yung mga given sa taas. Level of significance. In testing the significance of two small samples drawn from the two different populations, we shall use the t-test since the sample variances cannot simply be used as estimates of population variances. If the values of the sample variances are used, then we shall have some modifications in the computing formula for the value of t. In comparing two sample means, we shall test the null hypothesis against any of the alternative hypotheses. This is the formula on that case. Okay, let's take this example. ABC company, a manufacturer of automobile tires, claims that the average life of its product is 45,600 miles. So that's the claim. But a random sample of 15 tires was chosen and resulted to a mean life of 43,500 miles with a standard deviation of 3,000 miles. Based on the above results, test the hypothesis such that mu is equal to 45,600 against the alternative hypothesis. Mu is less than 45,600. Bakit less than ang ginamit yan? Kasi sabi dito, a random of sample 15 tires was chosen and resulted to a mean life of 43,500 miles, and 43,500 is less than 45,600. Yun yung sample kasi, 43,500 yung mean daw niya. So less than siya. Use alpha is equal to 0.01 and 0.05. So this problem, sinasabi niya na gamitin daw natin yung 0.01 and 0.05. Both level of significance. So let us try to determine the variables muna para hindi tayo mawala. Ang sample mean is 43,500. So makikita nyo naman sa taas, 43,500. Ang mu is, or the hypothesized value of the population mean is 45,600. That is the hypothesized value of the population mean. And the sample standard deviation is 3,000. And the sample size is 15. If you can notice, my dear students, the sample size is less than 30. 'Di ba kung sa z-test hindi na pwedeng gamitin ang z-test diyan kasi ang condition is that the sample size should be greater than 30. Pero dahil sabi ng t-test, pwede niyang gamitin ang t-test kapag less than 30 siya. Thus, we must use t-test. Using the steps discussed in the preceding section, we have mu is equal to 45,600 miles. So that is the null hypothesis, and the alternative hypothesis is that mu is less than 45,600 miles. We have two possible values. Kasi pinapakompute sa atin or pinapagamit sa atin yung both significance level, which are 0.01 and 0.05. So sabi kanina, kailangan nating malaman din yung degrees of freedom. The degree of freedom is n minus 1 is equal to 15 minus 1 is equal to 14. So that's the formula kasi for degrees of freedom, sample size minus 1. So the degrees of freedom in that problem is 14. Thus, when alpha is equal to 0.05 and the degrees of freedom is equal to 14, the tabular value is 1.761. So saan nakuha yung 1.761? Ginamit natin tong table na to for t-test. So, kung makikita nyo, ang degrees of freedom is 14. Ang intersection ng 14 na degrees of freedom and level of significance na 0.05 is 1.761. While ang intersection ng degrees of freedom na 14 and level of significance na 0.01 is 2.624. So, makikita nyo dito, ang tabular value natin at level of significance 0.05 is 1.761. And the tabular value at 0.01 is 2.624. Kasi importante na malaman natin yung tabular value kasi diyan natin i-compare yung yung t computed natin later. Okay, so we apply the formula. We use the formula 43,500 minus 45,600 times square root of 15 all over 3,000. So, yung 43,500 natin kasi, that's the sample mean, and 45,600 is the population mean, and 15, that square root of n, or 15 is the sample size, and 3,000 is the sample standard deviation. So, the t computed is negative 2.71. So, what is the decision then? We observe that the t computed, which is negative 2.71. So the absolute value of negative 2.71 is 2.71 is greater than the t tabular at 0.01 and 0.05 level of significance. Kasi 2.71 is greater than 1.761 and at the same time 2.71 is greater than 2.624. Hence, we reject the null hypothesis and accept the alternative hypothesis. Therefore, we can conclude that the average life of the automobile tires produced by ABC Company is less than 45,600 miles. Kasi nireject natin yung HO na sabi natin kanina, mu is equal to 45,600 miles. So, i-accept natin ngayon yung HA, which is that mu is less than 45,600 miles. Okay, so we move on to the last example for t-test. Two samples are randomly selected from two groups of students who have been taught using different teaching methods. An examination is given and the results are shown below. So, group 1 and group 2. Ayan, yung sample size ng group 1 ay 8, sample size ng group 2 is 10. The mean is 85. For group 1, mean for group 2 is 87, and the standard deviation for group 1 is 46, and standard deviation for group 2 is 36. Using a 0.05 level of significance, can we conclude that the two different teaching methods are equally effective? So ito, it makes sense na to sa field ninyo kasi nagtetest na tayo ng dalawang teaching methods. Yung isa ginamit niya is group 1 na estudyante, and yung group 2 group naman ng pangalawang estudyante. So, itetest natin yung kung merong significant difference yung dalawang group to determine kung effective ba yung equally effective ba yung dalawang teaching methods na ginamit sa kanila. So, this is the solution. The value of the degrees of freedom is n sub 1 plus n sub 2 minus 2. So if you notice kasi, dito meron tayong dalawang sample size which is n sub 1 and n sub 2. So the formula in getting the degrees of freedom in that case is that 8 plus 10 minus 2 is equal to 16. So the degrees of freedom is 16. Again, kapag dalawa ang sample size natin, my dear students, ang formula is n sub 1 plus n sub 2 minus 2. So 8 plus 10 minus 2 is equal to 16. The null and alternative hypotheses are as follows. The null hypothesis is mu1 is equal to mu2, and the alternative hypothesis is that mu1 is not equal to mu2. In words, when we put it into statement, ang ibig sabihin ng mu1 is equal to mu2 is that there is no significant difference between the two teaching methods. Okay, yun ang ibig sabihin niya, walang significant difference. Kaya nga equal lang sila. Pero yung alternative hypothesis, ang ibig sabihin niya, mu1 is not equal to mu2. There is a significant difference between the two teaching methods. Merong mas effective yung isa hindi naman ganun ka-effective. Parang yung ganun, yun ang ibig sabihin ng alternative hypothesis natin. Pero yung null hypothesis natin, ang sinasabi niya, equally effective lang silang dalawa. So the level of significance is 0.05. That is given. The tabular value at alpha or at significance level of 0.05 is T alpha all over 2, T.05 all over 2. Kailangan nating i-divide ng 2, my dear students, kasi ang pinag-uusapan natin dito is two-tailed test. Kasi ang alternative hypothesis natin, kung makikita nyo, is mu1 is not equal to mu2. Diba sabi natin kanina, na kapag ginamit natin yung not equal to sa alternative hypothesis, two-tailed siya. So, kailangan nating i-divide ng 2. Okay, so, para ma-determine yung tabular value natin, kailangan nating gamitin yung table. So, ang degrees of freedom natin is 16. Ayan, makikita nyo 16 ang degrees of freedom natin. So, ang alpha natin, kailangan nating i-divide ng 2, which is 0.05 divided by 2 is 0.025. So, yun yung magiging level of significance natin. So, the intersection of 0.025 and the degrees of freedom, 16, is 2.120. So, 2.120 ang magiging tabular value natin. So, I hope na gets nyo kung bakit natin dinivide ng 2, kasi ang alternative hypothesis natin is not equal to. It means that dalawa ang rejection region natin, or it means na two-tailed test siya. Okay, so kaya nga ang kinuha natin dito is yung intersection ng 16 and 0.025. So, ang tabular value natin is 2.120. Now, we can apply the formula, yung na-present kanina, that is 85 minus 87 divided all over the square root of 8 times 46 plus 10 times 36 all over 8 plus 10 minus 2. So, ayan, times or plus 8 plus 10 all over 8 times 10. So, ang T computed natin, applying the formula, is negative 0.625. So, i-compare natin siya sa critical value or tabular value natin, which is 2.120. Makikita natin na less than siya, 0.625 is less than 2.120, which is the tabular value. So, we shall accept the null hypothesis and reject alternative hypothesis. Kasi nga, kapag less than siya, the absolute value of the T computed is less than the absolute value of the tabular value, which is 2.120. So, we accept the null hypothesis and reject the alternative hypothesis. Thus, we can say that the two teaching methods are equally effective. Kasi nga, i-accept natin yung alternative hypothesis. I-accept natin yung null hypothesis, yung mu1 is equal to mu2. Ang ibig sabihin kasi nun, there is no significant difference. Meaning, magkasing effective lang yung dalawang teaching methods. Okay, so medyo complicated lang yung formula pero you can use your calculator later. Ayan, para makuha nyo yung T-computed. Pero my dear students, ang pinaka-importante dito is alam nyo kung paano mag-interpret using the traditional method. So dapat hindi nyo makalimutan na kapag ang Z-computed or T-computed ninyo is greater than the Z-tabular or T-tabular, kapag greater than siya, you reject the null hypothesis. Pero kapag ang Z-computed or T-computed ninyo is less than the T-tabular or Z-tabular, you accept the null hypothesis and reject the alternative hypothesis. So, yun, dapat wag niyong makalimutan yun. Balikan natin yung rule para hindi nyo, yun kasi ang pinaka-importante sa lesson na to. Okay, this is the rule. If the computed value is less than the critical value, we accept the null hypothesis. And if the computed value is greater than the critical value, we reject the null hypothesis and accept the alternative hypothesis. So, sa z-test naman, ang kailangan mong i-consider dapat dito is that the sample size should be greater than or equal to 30 and dapat normally distributed ang data mo. Pero dito sa t-test, pwede mong gamitin ang t-test kapag less than 30 ang sample size mo. Okay, so that ends my lecture for hypothesis testing for traditional method. Be ready for your quiz on hypothesis testing both on traditional and p-value method. Goodbye and stay at home, study well, and always pray, my dear students.